去到1.7。Okay, hello guys. We come to this, right? This is what we have done yesterday. We talked about some of the details of the experiments, right? So, and also I leave you two exercise for you to take home and try it. Is on question 21 and question 22. Any questions so far? Do you know how to solve the problem? Now, for those who can manage the two questions, could you please put a tick? For those who are not so sure, could you please put a cross? Let me know. Let me know if you can manage that two questions, 21 and 22. The question asks for some of the details of the experimental steps as well as calculations, mocap. Again, a tick. You think that you can manage? A cross. You think you cannot? Hello, how about the others? 李佩衡、鄧浩俊、黃俊熙、張思維、龐家謙、何孝日、梁家傑、李健樂、馬家樂、魏俊滔、譚君佑、黃成軒。Sorry, you just mark across. Which part do you find it difficult? Or you just want to put a tick and you need to answer my questions, right? How about the others? Any questions? 譚君佑、黃成軒、魏俊滔、馬家樂、梁家傑、張思維。You think you can manage? Okay, great. Now, so our recap for today is on the other part, is on the 3-step or 2-step, 4-step synthesis, right? What I mean is for just like question 14, 15, etc. Right? This is the core parts, one of the core parts in the organic chemistry synthesis experiment, and once every 2 or 3 years, here comes that type of questions, asking you to 3 marks or 4 marks on the synthetic steps. Okay. So how you count the marks, I would like to tell you by one by one. Okay, so start with question 13 has a warm up. I would like to check the details of what you have mentioned. Each one of you will have got a chance to speed up. Lam Seng Han. Question 13A. A student proposed the following route for synthesizing propane reactive from propene. So as X. What can be X?
CH3, CH2, CHOH.
Oh, so how would you call it? CH3, CH2, CH2OH. So what is it? How to name this? How many carbon?
Propanol. Propanol.
Yes, propanol. Propanol, okay? So give reagents and reaction conditions needed to carry out step 2 and step 3. Step 2 and step 3.
For step 2, let me see. It should be a heat with NaO aqueous NaOH solution under reflux.
NaOH heating under reflux. Yep.
Step 3, heat with MnO4 acidified MO. Wait, what? Sorry, give me a sec. It is acidified MN. No, sorry. KMNO4 aqueous solution under reflux.
Heat under reflux. Like this, right? It's possible, but if you want to have a safer method, we would usually use K2Cl27 because that chemical, the KMNO4 is the oxidizing power of it is too strong, so that may have a further cleavage of other parts. So this is what I would like to share with you. These two in your exam, these two they are also acceptable. Number 3, name the type of reaction that takes place in each step. 兩加結. What's the type of reaction? Step 1. Propene, I add HBr to form 1 bromopropane. The first one. Addition. Addition. How about the step 2? Step 2. Okay, 梁家傑, are you here?
Yeah.
So how will you know that the type of reaction, bromopropane, right? The bromo group has been changed to hydroxy group, a replacement of one group of atoms to another. So how we call the type of reaction? I kick out Br and I add OH. Now, the type of reaction that type of questions which is frequently asked, you better clarify with the type of reaction one by one. Okay, can I have anybody who can help? Yep, substitution. Yes, substitution reaction, SUBSITIUTION. So remember the spelling, or hydrolysis is also okay. How about step 3?
Oxidation.
Yeah, oxidation is a type of redox, right? So, but if you want to mention the organic compound undergo oxidation, while the oxidizing agent, the KMNO4 or K2CO7 undergo reduction. Okay, so this type of reaction. Explain why the student choice of reaction for step 1 would lead to a low overall yield. Low overall yield. Step 1. What happens to step 1? Now, isn't it addition, right? But why would we say that the low yield? Say Cheng.
因為佢有幾隻唔同嘅 product，
For example,
溫大部冇 propane，
1 dibromo-propane. How you produce that 1 dibromo-propane? How? By what reaction? By addition as well? Now I give you some hints. Propene, we've got structure here, right? So HBr. So we have got the product. If you want to mention 1 bromopropane, that should be this. Bromo is here, and the H I put it here. Right? Yes, we have got 2 bromopropane. We have got another chance. I think HA is a BR. Okay, we have got 2 bromopropane. While the 2 bromopropane, it is also formed, which is what? How you relate with word low?
A major.
Yes, major product. According to mechanical theory, okay, the hydrogen should be added to the carbon of the carbon-carbon double bond already having more hydrogen. So for this case, it is C here. So we have got H and H. While for the C here, originally it's just have got 1 H here. So you are going to add this one. So this is the major product. So the bromo, we have a higher preference to put it into the carbon 2. Indeed, 2 bromopropane is a major product, while 1 bromopropane is a minor product with a lower yield. Of course, if you think of that symplectic route, it is rather problematic. Remember, each step of it will have their own efficiency. Okay, we have their own percentage yield. But for the step 1, already chop it less than half, because of the major product is not the major product, because it's just minor product. So no need to mention something like mechanical loss, the reaction is not complete, etc. Right? So it will make the overall yield much lower than expected. So the step 1, in case you have a very small percentage, the more step that follows, even though the later step will give you 90 or 80% of the percentage yield, the overall yield is still low. Okay, remember that type of effect, it is just a multiple of one another. So it is not a good method to do so. Okay, so this is what I would like to get you aware of this. How about question 14? Now, please take a look at question 14 and question 15. They are more or less the same, with no more than 3 steps, with no more than 4 steps. Of course, with no more than 4 steps, that type of reaction is more complicated because you need to learn more about the route. So what you need to do is to get that map again. please take it out that map and take reference to it, and you are going to solve. Okay. Recall your memory. Please take out the map. Okay, if you really cannot remember all those, you may take reference to it now for the time being. At the very beginning is acceptable, but later on, the more you practice, later on you just throw them away. Can I have Leigh log to try out A part with no more than 3 steps? What do you think? No more than 3 steps. So what is the maximum step? That can be, that's up to 3, right? You may think of 2, or you can think of 1. You can. It depends on the whether or not you can follow those the map. How many steps can you think of? No more than 3.
I think 2 steps.
2 steps is enough, right? No more than 3 steps. 2 steps. So what is the first step?
Add concentrated hydrochloric acid, heating under reflux.
Or heating under reflux. So what will be formed? What is the type of reaction you're looking for?
Elimination.
Oh, elimination. Elimination. Which step? From step 1 or step 2? Step 1.
From step 1.
Step 1. So ketone. If I undergo elimination, what will be the product? Now take a look. Yeah. You go to
alcohol.
Alcohol. Now you are going to think of alcohol first of all. Actually, you need to think of alcohol first, and then you are going to remove the water to form a alkene. So the dehydration should happen in a step 2 instead of step 1. So dehydration. That is the second step. So the chemical to be used is on the excess corn H2SO4. Okay, and heating under reflux. Okay, you use console and heating under reflux. The dehydration will happen here. So you go backward. You need to go backward. So from ketone back to the secondary alcohol. What is the type of reaction? And you can think of the suitable chemicals. Anyone who can try?
Lithium aluminium hydride in dry eval， 然後就加 H3O plus
Type of reaction. What is the type of reaction? Yes, it's reduction. So you need to write down this LiAlH4. NaBH4AQ is also okay. Dry ether. And number 2, you are going to add 3 H3O plus. And or you use NaBH4 AQ is also okay. Do you understand? So the whole flow of doing such reaction is to have a reactor synthesis So think of the precursor of forming cyclohexene first. This is cyclohexene. So you are going to think it backward. Cyclohexanol is the precursor. While the cyclohexanol, it seems a bridging point between the ketone and alcohol back to the alkene. Okay, so here comes 2 steps. Of course, you may think of consol, or you may think of corn H3PO4 in replacement of consol to do the dehydration process. Okay, is that clear? So it's a 2-step synthesis. How about B? Do you know how to solve that problem? Step 2. B. Are you here? So what is that? It is say 8 might turn back to ester. Yes. Could you please tell me? Eight might to ester. So it will be quite difficult to know what is the 8 might, right? So you may just write down the full formula for this part. 8 might. And ester here, you may change a little bit by drawing that C double O and then C3. Now I do hope this will help. 8 might ester. Exit hydrolysis and then do esterification. Yes, that's right. Good. Exit hydrolysis and esterification. So how you write down the chemical? Exit hydrolysis. And you do the esterification. So what is the middle step? You are heading for making an exit. Okay, so if you call it exit, I can do it as an ester later on. So how you put that chemicals here? Yes, that's right. Mark and Margalo have made a very good suggestion. Exit hydrolysis and to do esterification. So what is the first step? What is the second step?
consol
Consol. Which one? Which step are you talking about? First step?
兩個都好似應該係
兩個都要 consol, is it? Both steps will involve consol. Indeed, for exit hydrolysis, the exit to be used is just dilute. Non-oxidizing exit is already okay. So instead, you use a consol, use dilute sulfur exit, or you use it dilute HCl, it is also okay, because you are going to heat it. Heating will speed up the reaction. You are going to heat it to form an exit. Now this time, for the exit, which undergo esterification, you also need heating. But if you allow more time for heating, what I mean is heating under reflux, it will produce a high yield. It will make the reactions faster and also making a high yield. And you need this as a catalyst. What else? I need one more chemical. What is the chemical? Yes, you are going to have this one. It's ethanol. Methanol. You are going, instead of adding the word alcohol, you are going to tell me what exactly the alcohol it is. You know the score amount. You use methanol. One carbon alcohol. Is that clear? Okay. Do you think you can manage? Now, if you want to do it slowly, please let me know. I will speed up. C part 5看1 Your turn. Can I shall I remove the first part? Okay, I need some space. This one across and out. Let me see if I have got the whiteboard. Yes, that's right. I just got the whiteboard. What is the third step? The third one is on this part, CH3 CHO. This is ethanol. I produce it finally as the corol ethane. Can you see that? So
reduction first.
Reduction. And then
And then substitution.
oh, okay, you're going to that reduction. So what is the intermediate? The product. What is the product in between?
Ethanol.
Ethanol. And you do the substitution later on, right? Or hydrolysis. Oh, it's a substitution reaction, huh? If it was a more proper word, substitution reaction. So the leaving behind is on the chemical. You're going to have aldehyde, primary alcohol, and then this one. Okay. So you're going to add what? How will you talk?
First, NaBH4AQ.
Yep. Followed by next step.
Con HCl.
Yep. Perfect. Con HCl. Or somebody who loves to use HCl gas with zinc chloride as a catalyst, right? Somebody would also love to write it down like this. Zinc chloride is a catalyst and hydrogen zinc chloride as a catalyst is also okay. Question is for C. D. Wow, a very complicated one. Very complicated. And you go to this. Access membrane, but for this part, right? So what is it seems like having a ring formation. Okay, so in between the step, one of the step is just to form a ring. Okay, it's a ring formation. So to connect that, and you may find some special features here. The special features is on here, right? That too is very similar. Can you see it? Well, that carbon with the O here, with the carbon with the O here is very similar. And you are going to count. We've got 1, 2, 3, 4, 5, and 6, and we've got 1, 2, 3, 4, 5, and 6, right? 6 member. Very similar, right? So the ring formation beforehand, which is that? It is what is that? Actually, you're going to check this one. What's this? It's an ester. We will call that a cyclic ester, a ring ester, cyclic ester. So, Dr. Hay, would you think of the procedures about that? So what is the step beforehand? Now you may think of a retrosynthesis first of all. This one ring formation, I form ester. So again, it is a type of esterification. Okay, so what was the step beforehand? Before this,
The aldehyde has to oxidize first.
aldehyde should be
Reduction.
reduction. Which one is aldehyde? Oh, this one. You mean this one? Aldehyde? This one? You are going to change this one first of all. This one, aldehyde.
Yes.
Oh, aldehyde. But take a look on this. This part, if you split that ester, you do the hydrolysis first of all. Think of you may think it in reverse, right? Hydrolysis. So what will be the product? So it will be something like this. Now, so how about these? These part. What is that? Which one is OH? Which one is COH? With the alpha
COH.
bingo on the left hand side or right hand side?
Right hand side.
Right hand side is COH, right? So this is COOH. So this is COOH. While for this one is OH. In other words, you are going to do such synthesis. You are going to only change what?
Oh,
That
that's
aldehyde to acid right on here. Can you see that? The aldehyde, that should be aldehyde. Now it's not just this. You are going to mark it again. This is aldehyde. Okay, I change it to acid. So this is oxidation. So what is the first step?
add acidified potassium dichromate solution and
Yeah.
heat under reflux.
Cr2O7 acidified, heating under reflux. And you can get it as a carboxyl group. But you take a look on, it's not reduction, it's oxidation this time. But yes, take a look on this alcohol. Alcohol will not be oxidized. This alcohol, will it be oxidized? Now you take a look on that carbon. The carbon we have got 4 groups, 4 connecting atoms. This one is methyl. This one is methyl. This one is alkyl group, or one on top is OH. In other words, this one is the tertiary alcohol. The tertiary alcohol will not be oxidized. Can you see that? So you will state it as OH. But if it is a primary or a second alcohol, you do the same chemical, of course, both group will be oxidized. So it's a very special case. While for if you think that the reverse of hydrolysis is condensation reaction, right? So what would you tackle the problem? It's not that. You think it reverse is hydrolysis. If you go in reverse direction, what should be added? Let you know. You want to make ester, right? Where is exit? Where is the alcohol? Where do we need to add extra acid or alcohol?
Yes.
Okay, so any suggestions? How about the compound itself? The compound itself will have got hydroxy group and the COH, which two will merge together, they will form an ester. So the answer for that is just using Consol. and heating under reflux, and it is okay. Why? The product itself, the reactant itself will have already got a group of hydroxy group. We have got a carboxyl group. So because of the lengthy distance, they can form a ring by itself. How will you know? You count it, please. So if you treat this one, the ester, the CO double bond carbon is number one, 2, 3, 4, and 5. Here comes methyl group, and then 6-member ring we've got O, right? You do the same thing. We've got 1, 2, 3, 4, 5, and this oxygen number 6. Do you understand? So you are now having a ring formation. It is a 6-member ring. So very often, if you check it on the web to get to know more about the organic chemicals, usually they will form a 5-member ring, 6-member ring, and 7-member ring. Why? Because about the bond angle is very close to 109.5 degrees. Okay, each turning point, they will have 4 electron centers adopting a tetrahedral framework. So this question D is a very special case. Could you please mark a star here? The chemical itself they will have bifunctional. It's bifunctional group, 2 functional groups. So that 2 functional groups, because of the distance quite lengthy, they can form a ring. Interesting, right? Very interesting. So any questions so far? Now, shall we move on to the second case? On E, we have got CH3, CH2, CHBr, CH3. You are going to produce CH3, CH2, CO double bond, CH3. The change in the chemical is on here. Bromo, this carbon is still here. I change it to ketone. Run it along.
Yes.
What do you think?
我先嚟一個 substitution 咯，即係用 NaOH heat under reflux。
Oh, substitution. You think of substitution. NaOH, right? You heat it under reflux. What will be formed?
alcohol 應該係一個
CH bracket OH.
Butanol
Okay, it's
2
a 2O. It's a 2O. So this one is hydrolysis or substitution reaction followed by
oxidation.
Oh yes, oxidation, because you are now changing the secondary alcohol to a ketone. Secondary alcohol to a ketone. So the chemical to be used is what? How? What chemical should be added?
Acidified potassium dichromate solution.
Yep, acidified K2Cr2O7. Heating under
reflux.
Yep, remember you need to mention the condition as well. K2Cr2O7 H plus heating under reflux. So this is what we call it as oxidation. So this is what you know about E part. Any questions so far? Any questions so far? Difficult? Somebody may say yes, because you need to be highly aware of the chemicals to be used, right? You need to think of the steps very, very carefully. So it is rather quite difficult to do. I know it's quite difficult. How about question 17? 17. You are going to suggest no more than 3 steps to accomplish the following conversion. It is not so surprising to see the chemicals having a ring, either ring opening or ring closing. Ring opening or form a ring is very commonly seen. Cyrus. Question 70. Okay, have a try on that. Question 70. This one with the ring. Yeah.
For question 17, first add water and dilute sulfuric acid.
Water and
Dilute sulfuric acid.
dilute sulfuric acid. Condition.
Heat under reflux.
Heat under reflux. What for is it? What is
I'm
the
sorry,
step?
can you repeat?
What is the step? What is the purpose of doing such? You're going to change this substance to
I'm going to change the substance. I'm going to change the ester group into a carboxyl group and a hydroxyl group.
ester, carboxyl group, hydroxyl group. So you may find the one the ring, the hexagonal ring here, these two will not be changed of anything. So you may find it. This is 1. Number 2, we've got O. We've got the 1. We've got 2. We've got that O. Can you see that? So leaving behind is on this. This is the carbon. We've got put a star here, and this is the carbon, and we've got the OH. So the first of all, you're going to split the ester into carboxyl group and also and hydroxy alcohol. So you do the same thing. You're going to draw the hexagon here, and what will happen to these two chemicals? Which is which?
The top one is the acid.
The top one will go back to acid. Bottom one is alcohol, right? The primary alcohol. Okay, so the reaction is acid hydrolysis. Okay, so what is the second step?
Add lithium aluminum hydride in dry diethyl ether and add a few drops of dilute sulfuric acid as well.
Later on, okay, later on, but not that follows. That continue by followed by, okay, but not
Okay.
together. Dry diethyl ether. And this is what? What's the type of reaction?
Reduction.
Reduction. So the reduction of this part is the carboxyl, COH. You go back to the primary alcohol. Okay. How about this? OH and OH here, no change. Okay. The reducing agent will have no action of this OH, will stay at the as this. So question 17 will be this. Questions? Questions? Find it difficult, easy, or what? Lim Junhee. Now, can we have a try on the next questions? For 15, we go back to 15. You're going to change the chemical to another one. We've got a phenol propanamide, right? Phenol propanamide. So the reactant is phenol propanol. Okay. So you need not think of the benzene. Okay, benzene will have no chemical reactions, just stay there. You need not tackle that.
I think the first step.
Fourth step, right? It's quite difficult at the very beginning, right? But you think of the precursor. What makes the amide? You may think like this way. You find it difficult because you need to deal with that so many groups at the very beginning, and you need know how to get approach to this later on. So you better.
I should add H2 and with PT and 1 ATM.
H2. You do the you the first step.
It's the first step. I do both. I did it together. Just H2
hydrogen and then
PT
room temp. Okay. Room temp is enough.
1 ATM. 1 ATM.
1 ATM, yes. 1 ATM。
好似有天上阿黃希咧個 Zoom 彈咗，佢已經 waiting room 嗰度好似。
Yes, I added back. Thank
Okay.
you. So break pressure. And what's next? So what will we get? It's on the product, the intermediate. What is the intermediate?
So
what happens to the CC double bond?
I think it should be CH2, and CHOH.
CH2OH, right? So you need to do both. You have going to do both, right? Both CC double bond and aldehyde will have got hydrogenated. CC double bond, they will turn to CC single bond. Aldehyde is a undergo reduction. So if we talk about the type of reaction, it's very special. For this part, they will undergo addition. This part, we call that reduction. Okay, is it also reduction as well? This one can also tell it as a reduction. To form this, that primary alcohol. What's next?
Then add KCl2O7 in acidified potassium
dichromate.
Heating under reflux.
Yes, heating under reflux. So what will we get? Primary alcohol to
phenol and CH2COH.
Oh, COOH. You want to turn to alcohol from acid. Okay, from alcohol to acid. The primary alcohol to acid. Okay, so the type of reaction is oxidation. So this is what's the next step? This is the 8-mide formation. We call it condensation reaction. So any suitable chemicals?
NH3 and heat.
Yes, possible. Okay, NH3AQ and heat. is also okay. So you may get, remember, heat is a very important item. Otherwise, if you do not heat, just add ammonia here. So the answer will be this. So it is not, it's not a amine. You are going to further heat. Before you come to amide. Okay, it's just an ammonium carboxylate salt. It's a type of salt, ammonium salt. Okay, is that clear? So how many steps do they take? We have got 3 steps. Okay, if I use Ronald's suggested 3 steps, and you can get what you want. Any questions so far? Question 16. Question 16. You are provided with chloroethane, inorganic reagents, and organic solvents. Outline the synthetic rate with no more than 4 steps to obtain ethyl ethanoate. Just this. For each step, give the reagents, reaction conditions, and the structure of the organic product. Very strange. This question is very strange. Why? Because for the making of ester, you need 2 organic chemical, right? But the only organic chemical given is chloroethane. So which means that both ingredients should come from the chloroethane. Can you get my point? So this is why this is rather complex. How you can approach the problem?
咁整咗 ethanol 再整 ethanol acid 之後再 combine 埋一齊。
Yeah. So to elaborate more, so first of all, you to think of this, the chloroethane is on here. CH3CH2Cl. Finally, you want to produce it as a CH3COO, CH2, and CH3. Okay, so this is what it is, an ester. While the ester here comes 2 chemicals. 2 chemicals. How would you draw the arrow? Very strange, huh? How about this? No, in reverse. Two chemical merged into one. Here. Is it like this? So you may have this one being CH3COOH. You may have, this is from the exit here. While heat this, the alcohol, so you may think of this CH3CH2OH. This is the alcohol. So the first step, the final step, it is esterification. So this is esterification. Okay. So which means that you are going to produce the other 2. How you get this?
Substitution.
Yeah.
Hydrolysis.
Chemicals.
NaOH under reflux.
Heating under reflux. Yes, that's right. So it is hydrolysis or substitution reaction. First of all, to get this. So, but one more point is on here. How would you get from alcohol to exit?
Oxidation 啊嘛。
Oxidation.
Acidified potassium dichromate solution, heat under reverse.
Yeah, good. Correct. So the approach that will be this. Do you find it complicated? Do you find it complicated, right? The whole procedure will be this, right? First of all, you are going to change the chloro group, chloro here, to hydroxy. Okay, this is the first step. Well, after the first step, you are going to split the chemical into two. You make it half. To split it into two. Half of them I do oxidation. Half of them retain it as alcohol. Half of them I oxidize it to form an ester of acid, and I use another half to react with the original half to form an ester. Do you understand? So here comes one step, two, second step on here, and third step here, 3 steps. While the second step is a very strange step in which you are going to split the chemical into halves. One, you keep it for later esterification. The other half, I oxidize it to form an acid. While the product, they will put it back into the reactant and do the esterification. So remember, esterification, I need a catalyst. Say, remember, just add consol. By doing so, you can do this. Interesting, isn't it? I nearly finished most of the questions in the structure type question, isn't it? 係咪完做晒㗎啦？差唔多做晒㗎喎。18, question 18. I did not do this, right? Let's have a try on that. 咦，我跳唔返出去嘅喂。Yes. Do you see it? 咦，未有啊。Why connecting? Very strange. Do you hear me?
Yes, we hear you.
Yeah. 18. Question 18. Or maybe some internet connection problem. So 18, benzymamide, benzoic acid, benzyl bromide. They're commonly used organic compounds. The structure shown, they are shown below. In experiment, if phenolic acid is prepared from benzymamide into 2 steps. Blah, 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 blah. Oh, it seems like, what is the type of reaction? What is the type of reaction?
Hydrolysis.
Yes, a type of
alkaline hydrolysis.
Yes, first step is alkaline hydrolysis. First step is alkaline hydrolysis. So what is second step? What is the second step intended to do? It seems like acidification, right? You want to acidify something. So X should be acidified. What is X? Draw the structure of X. How you call X? How you call X? Wang Xinghian, are you here?
Yes.
So my question is, what is H? Ammonium benzoate. Agree?
應該 sodium 啊嘛
Yes,
，sodium
sodium.
benzoate。
Yeah, it's just sodium. It's sodium benzoate. So COO minus and Na plus. Okay. So just what Y would be. This time I give you one more chance to what would Y be? Acidification. Acidification. Well, exit is possible. Is the thing over here?
Sulfuric acid 啊 ，hydrochloric acid dilute。
Dilute. Remember, you need to tell the word dilute very clearly. Hydrochloric acid or sulfuric acid. Strong acid, but non-oxidizing is enough. HCl, HNO3, no way. Never use nitric acid. Okay, suggest why X is more soluble than ethanol acid in water. Now, very strange. Very long answer about this because you need to tell both the solubility of benzoic acid in water and X in water. You need to tell the difference.兩邊比較啊，有冇答到？何偉林。What's X sodium benzoate. Ionic compound. So, which form? What attraction form with water? How about benzoate? Term. These two. Do you know the term? These two. Yeah, first one, iron dipole. How about second one?
Hydrogen bond.
Yep, hydrogen bond. So, iron dipole attraction is a stronger attraction force when you compare with benzoic acid and water, which is for hydrogen bond. It is just a matter of comparison. Okay, of course, if you want to compare hydrogen bond with van der Waals force, hydrogen bond is generally stronger. But this time, when you are going to compare iron dipole attraction and hydrogen bond, this time iron dipole attraction is stronger. So what is mean by iron dipole? Iron refers to sodium ion and benzoate ion, while dipole refers to what? Water. Okay, the water itself is a highly polar substance, so it will give you a permanent dipole, so we will call that a dipole. Can you get my point? A polar substance. So the polar substance that can also react having a attraction with some ions to form iron dipole attraction. As said before, if you still remember in bonding and structure that questions, here comes the iron dipole attraction, which help you explain why sodium chloride dissolve in water. So you may draw water like this, having the oxygen with a lone pair electron surrounding the sodium ion. So the iron dipole attraction is on here. Do you still remember that? The iron dipole attraction is found here. Okay, questions? How about, oops, wow, I nearly make the bottle topple. Now, what happens to the number 5? Describe how a dry benzoic acid can be obtained after step 2. So after I add acid, the benzoate will turn to benzoic acid, it will form a solid. So what should we do? What should we do next to get a dry product? So you're asking for the steps. Do you realize you are going to ask for the steps later on? The solid is benzoic acid. So first of all, filter. You're going to fill the mixture to obtain the solid. So what's next? Wash it.
Wash it with dry cold water, cold deionized water.
Yes, you are going to wash it with little amount, okay, of cold distilled or deionized water to wash away the water soluble impurities, and then dry
it by pressing it between 2 pieces of filter paper.
Okay, yes, or put it inside desiccator is also okay, and dry it with the desiccator. Or dry it with pieces of filter paper, pressing in between with the paper is also okay. So again, filtering, washing, and drying. So is the way once you get the product, it's solid benzoic acid. Okay. Finally, outline the simple step with no more than 3 steps to accomplish the conversion of benzoic acid to benzyl bromide. So you start from benzoic acid. You go it as benzyl bromide. Benzyl bromide, CH2Br. No more than 3 steps. How you get approach to the problem? 你配啊
Reduction.
Yes, first of all, reduction. The chemicals.
LiAlH4 dry diethyl ether.
Followed by acid. Okay. Reduction. To form what?
To form
Immediate.
alcohol.
Yeah, alcohol, CH2OH. And then the next step seems easier, right?
Substitution.
Yeah, chemical, please. And the condition.
HBr.
Yes, on HBr. So you may get it as BR. Two-step is already okay. Okay, or you may use phosphorus with bromine to form PbR3, etc. Right? You can get what you want. Oh, we have covered successfully chapter 32, all questions. Quite nice, isn't it? Now here comes the next chapter in the next lesson, chapter 33. Important organic chemicals. So today, what I've just covered with you is on the mainly is on the conversion, 2-step, 3-step, or even 4-step synthesis. Which part would you find it very difficult? Is it the ring closure or the ring formation? Right? You may see that just like D is rather complicated, right? So the way to solve is by checking some of the special features, okay, on reactor places, and they are the number of carbons. You track it one by one, and keep track of the whole structure, and you may know the change in the functional group. And later on, you can solve what you want. Now, so this is what makes the whole case complicated. Now, no need to mention some of the basic stuff, which includes the memorization of the reactants and the conditions for the certain different types of the reactions. Now, NABH4 and LiH4, it is a commonly used reducing agent because in general, we will think of intermediate having an alcohol, ester, aldehyde, ketone, etc. Right? All those, they are just the middle point of the whole reaction. What else is on what? Oxidizing agent, right? Acidified dichromate, acidified permanganate. If you write down simple distillation or heating under reflux, the product will be different. And you may find some more difficult tasks, just like hydrolysis and condensation, in which you may see it very often in biology, right? The formation of ester, the breaking down of ester. Now, just like breaking down of triglycerides in oil, right? It is a type of hydrolysis. It is something about biology. Also, you have to revisit the biology topic again. How about amine? Amine, I try to break down the peptide linkage, okay, to form the smaller peptide as well. So it's a type of hydrolysis. If you go back to the amino acid, a butyric is a huge protein molecule. Okay, you are thinking of condensation as well as a hydrogen bond formation later on. So this is what I would like to share with you about this. Do you find it interesting? Funny? Right? I'm sure you will enjoy the beauty of organic chemistry. Here comes one more chapter to go. Okay, it is chapter 33. Any questions so far?
天 Sir，天 Sir，
係
今日啱啱第18題嘅嗰個part A part 第5喎，我唔係點明？佢 step 2之後佢冇晒 solid，咁點 filter 啲 solid 出嚟？
佢 step 2係講緊 until no more solid benzoic acid is given out, which means that the precipitation process has completed. So what is expected in step 2? If you record, if you imagine what is happening is that if once I add acid to it, those sodium benzoate will be reacted backward to form benzoic acid. While benzoic acid is not water soluble, so precipitate is formed. The more acid is formed, is added, the more benzoic acid is formed. They were, but the benzoic acid is just a limiting, right? So finally, if I further add acid until the point where no more benzoate is found, so of course no more solid benzoic acid is formed. So this statement, step 2, means like this. Do you understand? 明啊？嗬，就唔係話加咗啲酸咗去冇固體咯，係加啲酸落去就開始有固體啦，繼續加到去唔會再整到多啲嘅固體。
跟住佢本身又唔係幾溶嘅。
係啦，咁咧 so you may see the step part 4 suggests why X is more soluble than benzoic acid in water。所以咧 benzoic acid 咧通常喺凍水嚟講咧就係唔溶喺水㗎，放熱水咧就溶嘅。咁啊有啲咁呢個你要認識啦 ，OK 得唔得？
同埋下面我影一影相，下面
咩話
boy part 嗰度我影一影相，我抄低。
好啊，呢度係咪影晒定係 B 啊
B 啫，
定係 B？
唔該晒。
OK， for B part is this。好 ，any more questions？ 有冇人做緊嗰個 supplementary exercise 㗎？入邊咧好多啲 conversion 可以玩嘅喎，即係有人可能做到興合㗎嘛，哇好正啊，唔做唔得啦咁樣咧嘅同學嘅話咧，你就要做 supplementary exercise。我一陣間 highlight 某啲題目啦，你哋可以翻去做。其實書後邊都有㗎，書後邊turn to page 231， 231頁 ，question 31。You may find this conversion set 36C is also a conversion step。呢啲都幾得意嘅，你會見到咧好多得 past paper， 而 past paper 咧最乞人憎咧就係成日都要 form ring 嘅，所以鄧俊熙你要面對㗎啦，你淆底都冇用㗎啦。譬如30嗰啲啊，鄧俊熙你今日做完之後 send 俾我。睇你減下點 ？OK， 有咩問 ？Now if not, enjoy lunch now. Okay, see you guys. Bye bye.